Good afternoon, everyone. For the second part of review, we're going to be looking at the graphs of the sine and cosine functions and their properties and how to make an equation. So here is your executive summary of those properties. We graph in sine and cosine. Sine starts at the center line. Cosine starts at a peak. Center, trough, up, repeat. The period of both functions is by default 360. Amplitude is half the height of the curve. Period is the distance of the cycle. Peak point is when the curve gets up there. Trough point is when the curve gets down there. Center axis half between the peak trough. To graph this information is enough. Repeating pattern mean the graph ain't so tough. Sine, sine, cosine, sine, sine, cosine. Thanks. Okay, so now that we've had our fun, let's get on to an actual example to review this in a little bit more detail. So there's that function that was up there earlier. So we're going to use this as our template to review the actual properties here, okay? Because we'll just get all the key information and talk about how we would create the graph. So the first thing, okay, is we're going to want our amplitude. Okay, so yes, this is the serious part of the note. You can start writing this down now. So for our amplitude, okay, that's just our leading coefficient here, right? So our amplitude is going to be 2. Okay, and again, the reason that is because it's the vertical stretch, and that's what's telling us about that part. Okay, to get the period of the function, okay, that comes from here, the horizontal stretch or compression. Okay, and the period is always 360 divided by what that value is. So 360 divided by 45 is, I think that's 8, but I'm just going to check. Okay, 8. So this graph will repeat in 8. Okay. The next part, continuing left from right, okay, is the phase shift. Okay, so we have a phase shift of 1. Okay, and finally, we have a vertical shift. So the vertical shift is tied to the center axis. So now we have all those pieces. We have information to make a rough sketch of the graph. Ooh, let's straighten those up. Okay, so the first thing I'd like to start with is our center axis. Okay, center axis is 3. So that means at 3, I'm going to just mark that out. Okay, that's where the middle of this function is going to be. Okay, the phase shift is 1. So that means I'm going to be starting at 1. It's sine, so I'm going to start in the center axis. Okay, phase shift is 1. Okay, the period is 8. Okay, so again, this is 1. So on my graph, a full cycle occurs in 8 units. So somewhere down here is going to be 9. Okay, and that's when sine will return to the same part of the graph. Okay. So to help with the graph, we're going to break this up into 4 equal sections, right? So a quarter of the period would be 2. So every 2, so if I split that in half, that would be 5. And I split it again, there's 3 and 7. Okay. So that means the key points happen at each of those quarter periods of the graph. Okay. So for instance, okay, the 5 is going to be another trip to the center. Okay, to get our peak and our trough, okay, that's where the amplitude comes in. So our amplitude is 2. That means my peaks will be 2 above the center, so at 5, and my troughs will be 2 below the center, which is at 1. Okay, sine starts at 1 and goes up. So at 3, I'm going to have a peak. Okay, and at 7, I'm going to have a trough. So putting that all together, my curve should look something like this. It goes up, comes back down, goes back up, and repeats. Okay, so again, that's how you use those 4 features to get a rough sketch of what the graph would look like. For our second example, we're going to go the other way. So we're going to start with a curve. We're going to use that to find the equation. So the key things here, right, I'm looking for my amplitude, the period, the phase shift, and where the center line is. Okay. So again, I'm going to start, again, kind of going through them backwards, but I'll start with the center line. Right, the center line looks like it's right here on this graph, and I kind of missed. So we'll try that again. Right, my center line appears to be right along here. Okay, and that's occurring at 4. Okay, so that means I have a vertical shift of 4. Okay, for my amplitude then, okay, the amplitude is the height of the curve. Okay, and going from the center line, it peaks here and troughs here. So it appears that my amplitude is going to be 1 unit, okay, because it's going up to 5 and down to 3. Okay, for the period, I need to find a point and see how long it takes to repeat. So if I go back to my original peak that I marked over here, my period of the function is going to be the distance from here to the next peak, which is there. Okay, so it starts at -1. Right, if I look down here on my axis, okay, it's starting at -1, it's ending at 9, so that's a distance of 10. Okay, the period of the function is 10. Okay, so working backwards for a second on the side, right, that means 360 divided by 10 is going to equal the value I need in my equation. So it's 36, okay? Last thing is a phase shift. Okay, and for this we have to decide which model we want to use. Okay, the simplest model for the phase shift would be to choose cosine, because I just go right back here to the peak and I'm ready to go. Okay. If I wanted to do sine, I would have to do a phase shift all the way over to here at 6.5. Okay, so again, typically we try to take the shortest one. So we're going to use cosine for this because the peak is close to the axis. Okay, so let's put all that together into our equation now. So our equation is y equals, so my amplitude is 1. I'm going to write it there even though I don't really need to. It's 1. We chose cosine. Period was 10, so the value of b that gives me that period is 36. Okay, we have a phase shift of 1 to the left, so x plus 1. Okay, and the center line is at 4, so it's plus 4. Okay, and there's the equation that models the relationship. Okay, for our last example, we're going to talk about setting up a model from a word problem. Okay, so example 3, a child in a wave pool is floating in an inner tube. The depth of the water is 1 meter. Okay, when the waves come by, they peak at 1.2 meters and they have a trough of 0.8. Okay. Create a model for this situation starting with even water. Okay, so again, if it helps, okay, a rough sketch of the graph can really help show what's going on here. So I'm just going to do a quick sketch on the side. Okay, it says the depth of the water is 1 meter, right? So that means when there's no waves, okay, that the water level is going to be at 1 meter. So something like this. Okay, so the waves peak at 1.2 meters, I have a trough of 0.8 meters. Okay, and I'm realizing I forgot to put something about the time in there. So we'll add that in. cycle. Here's one cycle. Okay, so say that it goes from peak to peak every 6 seconds. Cool. So, right, we're going to start eating water. Okay, our period is going to be 6. Okay, and we need to break this up into 4 equal parts. Right, so there'll be 3 and 0, 1.5, and 4.5. Okay, peaks at 1.2, so that's a little bit above 1. Okay, back to the center. Trough is at 0.8, so our model looks something like this for the waves. Okay, and now we have what we need to set up the equation. Okay, so y equals, okay, our amplitude, okay, is that little distance there, so that's going to be 0.2, right? It rises 0.2 meters above and below. Let's try that one more time. Okay, because it starts at even water, okay, it'll be easiest to model this in terms of sign, and then we don't have a phase shift. Okay, for the b value, okay, again, our period was 360. This is going to occur in 6 seconds. Okay, so that's going to give me 60 as my value for b. So that's sine of 60. Okay, there is no phase shift because we're using sine. So that's going to be 60x. Okay, and then my center line is at 1, so it would be plus 1. Okay. So again, there's your kind of summary of how to sketch sine and cosine curves and how to create their equations from a graph and from a word problem. Okay, so for some practice, here's some questions from the textbook that would be good to use to do some review. Okay, so on page 405, number 9, 10, 12, 13, 14. Again, I encourage you, if you want to use the whiteboards, right, to get into small groups and practice a little bit together, or of course you can work at your seat. Just again, keep in mind that we're trying to study here, so it shouldn't get too noisy as you're working away at this. Okay, thank you very much for watching, and I hope to see you tomorrow.